Hey everybody, Sloan here again, and I'm back with another video in my web development adventure vlog. And it's been a while since my last video. Been really busy following a lot of courses, taking some classes online like CS50 from Harvard Distance Learning, and solving a lot of algorithmic problems, following some advice from Alvin from CodeByte and good people at freecodecamp.org, who've put together a really good course and a guide to help solve a lot of these really common algorithmic problem-solving challenges that are found in interviews for jobs, etc. So just maybe this could help you out as well if you're on the same journey as me, and also maybe demonstrate some of my learning so far in terms of how I solve some of these problems. So on the screen here, you'll see this is an example of a solution and a lot of notes and descriptions to help out along the way to solve the countConstruct challenge. In this challenge, the goal is to write a function that accepts a target string and an array of strings, and the function should return the number of ways that the target can be constructed by concatenating elements of the word bank array. Now, in this, you can reuse elements of word bank as many times as needed. And so, following Alvin's advice, I've come up with a solution to an easy example. And then here's the tree as well. And this part of the process has really helped me understand and visualize the problem conceptually in order to find the appropriate base cases to be able to start to build the brute force solution, which is the first step in getting to an efficient problem. So first, this describes how to reach the target of A, B, C, D, E, F using words from this word bank that's in this array right here. You can see there is one way to construct A, B, C, D, E, F using these words right here. Following the tree, we get to a base case that should return 0 because we still have some letters left, which means we did not reach the goal base case, which is an empty string, which would return one way to create this solution, and which would bubble up to the top. So for the sake of time, I'll skip the brute force solution and jump down here to the second step, which is the fun part, which is where you can really see the increased efficiency from the use of memoization. So initially, when I ran the program to come up with the solution for the final challenge here was 16.7 seconds. You can see afterwards, running the second one, it was down to 0.294 seconds. And how to do that? Well, the keys to memoization that I'm realizing can be applied to many of these problems is first to add the empty memo object in the beginning, then add an early return if the target is in the memo here. Third, we want to add the memo and pass it down to any recursive call. So in addition to the word bank, we have the memo here. And then finally, quite simply, we take the return, store it in the memo by replacing return, and then finally return the memo after storing it. Okay, so it was really fun to come up to find these solutions, to see how recursion works, and I'm excited to see in the next steps how tabulation can increase efficiency as well. I'll leave it there for now. I can see the comparison between brute force and the memoized complexity as well, which is really nice to see how it affects both the time and space complexity. But I'll save the rest for later. Until then, keep coding and code for the good. See ya.